Hello everyone and welcome to a new lecture. In this video we are going to talk about binary base. So from the name of it, binary means 2. Okay, so in this base or in this number system we have two numbers. We have two symbols and they are 0 and 1. So binary base is a number base that expresses numbers in binary numeral system or base 2 numeral system. And typically, as I mentioned, it uses 0 or 1. Okay, so instead of having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as we have it in base 10 or in decimal base, in binary base we only have two symbols. We only have two numbers and they are 0 and 1. And we can express a lot of things with just 0 or 1. Okay, so for example, computers, they express colors, they express letters, they express sentences, paragraphs, actually everything that you do on your computer. Behind the scene, 0 and 1 are representing everything. Okay, so you might say, well, just 0 or 1, you cannot do a lot of things with just two ingredients. Actually, everything your phone does, everything a website does, everything, for example, your computer does, every input that you put into your computer, they are all represented in 0 and 1. So binary system or binary base or binary numbers, they are simple but extremely powerful. So let's take a short break and let me tell you where the idea of 0 and 1 for computers came from, or why did computer scientists decided to use binary system for computers or in building computers. Actually, the idea comes from the fact that suppose you have a switch. Okay, suppose you have a circuit like that. We have a light bulb, a happy face, we have a battery, and then we have a connection or a circuit that connects everything to everything else. Okay, so suppose this circuit is off. Okay, they said that if the circuit is off, we will represent it with 0. This circuit right here is open, it's off, therefore we will represent it with 0. They said that if the circuit is closed like this and an action is happening, then we will represent it as 1. Okay, and inside your computer or inside your phone, there's a processing unit that has a lot of these circuits or a lot of these switches, and they are all either, sometimes they are 1, sometimes they are 0, collectively sometimes they are all 1, collectively sometimes they are all 0. So inside the chip or inside the processing unit or inside your computer, millions of these switches exist and they all operate under this language or under this condition. They are either 0 or they are either 1. That's why binary system or binary base is the language that computers can understand, because they can either be off or they can be on. That's the only state. So getting back to the mathematic parts of it, so we have decimal and we have binary. So let me show you some examples of decimal numbers and the equivalent of the binary number of it. So 0 in decimal is just 0 in binary. That's straightforward. 1 in decimal is 1 in binary. Okay, however, after 1, since we only have two symbols, we have to represent everything that we have in decimal, for example, in base 10, in a certain way in binary. Okay, so 2 in decimal is 1 0 in binary, or 1 0 in binary equals to 2 in decimal. Okay, 3 is 1 1. Okay, and 4 is 1 0 0. Okay, 5 is 1 0 1 and 6 is 1 1 0. And I think you can see the pattern. So after 1, when you get to 2, so if you remember when we got from 9 to 10, we said that we had the bucket that contains 10 elements and then we have another bucket that does not contain anything. So that's why it represents as 1 0 after 9 for decimal base or base 10. Okay, the same goes for here. So after 1, since we don't have any place to put another number or we don't have any expression that can represent 2 for us, so we will say we will hop 1 over and then we will put a 0 in the place, so it will be 1 0. Okay, when we go to 3, this place which is 0, we can make it another value, we can turn it to 1. Okay, that's why 1 1 is 3. For 4, since we don't have any places, all the buckets are full, I have to hop to another position. Okay, that's why I'm creating another position. I'll put 1 right here, as you can see it, and the other two positions that I already had, it was occupied by 1 1. Now I'll turn them to 0 0. So the pattern goes, and this is how we can create, or this is how we can represent decimal numbers in binary. So 0 is 0, 1 is 1, 2 is 1, 0, 3 is 1, 1, 4 is 1, 0, 0, 5 is 1, 0, 1, 6 is 1, 1, 0. So now let me show you how we can turn, or how we can convert decimal numbers into binary numbers. It's a very, very easy process, straightforward, and I think it will be very helpful to you. So suppose we have this. So we are trying to convert, for example, 5 in base 10 into a number or its equivalent in base 2. And 5 in base 10 is equivalent to 101 in binary base or base 2. So how did we get there? Well, all you have to do is just divide by 2, okay? And do this process from right to left, okay? So we have 5, we will divide by 2, we get 2, and then we will divide by 2, we get 1. Okay, as you can see, I'm doing from right to left. Just divide by 2 and don't care about anything else. So 5 divided by 2 is 2, 2 divided by 2 is 1. Okay, and then what we're gonna do is we will put 1 for odd and 0 for even. Okay, so 1 is an odd number, therefore I'm gonna put 1 underneath it. 2 is an even number, therefore I'm going to put 0 underneath it. And then 5 is an odd number, therefore I'm going to put 1 underneath it. This method of turning decimal numbers into binary is very, very simple and very, very straightforward. Okay, so by a simple process of dividing your decimal number into 2 every time from right to left, and then underneath each number, the ones that are odd, you put a 1 underneath, and the ones that are even, you put 0. You can turn your decimal numbers into base 2 or into binary numbers. Let me show you another example. Suppose we have 21 in base 10. 21 in base 10 is equivalent to 10101 in base 2. Okay? And the way we did this, we're just going to divide 21 by 2. So 21 by 2 equals to 10. Okay, it's not equal to 11, it will equal to 10. You'll have a remainder of 1, but don't care about that. Just divide by 2 and see what's going to happen. So 21 by 2 equals to 10, 10 by 2 equals to 5, 5 by 2 equals to 2, and 2 by 2 equals to 1. Okay, and then I'm going to put 1 for all the odd numbers and 0 for all the even numbers. So this is what I'm going to get. I'll have a 1 right here, a 0 right here, 1 right here, 0 right here, and 1 right here, okay? Because 10 and 2 are even, 1, 5, and 21 are odd. And this is what I got. As you can see it, 1, 0, 1, 0, 1, which is equivalent to 21 in base 10. That is basically how you can turn a number in base 10 into a number in base 2. So now let's do the opposite. Let's see how we can turn a number that was in base 2 into a number that is in base 10. So we'll do it opposite. So suppose we have 10101. This is equivalent to 21 as we saw it. How can we turn this into a number that is in base 10? Okay, well, it is very, very easy. So these are our numbers. We have 10101. And what you're gonna do is you're gonna bring powers of 2, and you will start from 0. So 2 to the 0, you'll put it enter the first one that you have, okay? And then 2 to the 1, enter the second number or the second digit. 2 to the 2, enter the third one. 2 to the 3, enter the fourth. 2 to the 4, enter the fifth, and so forth. So if I have other digits right here, I'll put 2 to the 5, 2 to the 6, 2 to the 7, and so forth. And then I'm gonna cross out those 2's that are underneath 0. So I'm gonna cross out these two, this one and this one. Since they are underneath 0, this one is underneath 0, I'm gonna cross them out, and then I'm gonna calculate. Actually, I'm gonna take the sum of all of them. So 2 to the 4, it will be 16, plus 2 to the 2, it will be 4, plus 2 to the 0 is 1. So 1 plus 4 equals to 5, 5 plus 16 equals to 21. And this is exactly what we have. 10101 is equivalent to 21 in base 10. And we did this conversion in this simple way. You put 2 to the 0 under the first number, 2 to the 1 enter the second, 2 to the 2 enter the third, 2 to the third enter the fourth, and 2 to the fourth enter the fifth number, okay? And then you will cross out those 2's that are under 0, and then you will take the sum of all the 2's that have a certain power, and then you will get your number in base 10. Okay, as simple as that. Let me show you another example. Suppose we have 1 0 0 0 1 0 in base 2. This is equivalent to 34. Okay, so how can we turn this into how can we turn this number, which is base 2, into a number in base 10? Well, it will be the same way. Okay, so these are our numbers: 1 0 0 0 1 0, and then I'll have 2 to the 0 under the first one, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. And I'm going to cross out those 2's that are under 0, which are these. We have 1, 2, 3, 4. I'll cross out all of them, and then I'm going to take the sum of 2 to the 5 with 2 to the 1. So 2 to the 5 is 32, 2 to the 1 is 2, 2 plus 32 equals to 34, and that is exactly what we have. So in this simple way, you can convert a number that is in base 2 into a number that is in base 10. So if you go to the description of this lecture, I have put 2 links. One of them is to convert decimal numbers into binary numbers, and the other one is for you to convert text. Okay, so if you write words, it will turn it for you into binary numbers. So the representation, so for example, if I say I like mathematics, it will turn that text into binary numbers. And I think it will be very, very fun. So you can text your friend in binary and have them figure out what it means as a game. Okay, so I encourage you to check out those 2 links and play with it and see how you can turn decimals and how you can turn text into binary numbers. And with this, we come to the end of this lecture.